Now that we have discussed the definitions of this chapter, it's time to start thinking a little bit about what is thermodynamics about. Okay, so with thermodynamics, we are thinking about reactions. And the one thing that we have to realize in a reaction is that you are breaking and making bonds. So let's think a little bit about the reaction of hydrogen plus chlorine to give 2HCl. Okay, so here we are breaking a hydrogen bond and breaking a chlorine bond. So here we need the energy to break both the hydrogen bond and the chlorine bond. And then we are making two hydrogen chlorine bonds. Now, when you want to break something, when you want to break a bond, this is always endothermic. Okay? And endothermic means that this will require energy. Okay? Therefore, will require energy. On the other hand, okay, anytime we make a bond, okay, it will be an exothermic process, which means that energy will be released. So we can say that bond breaking is endothermic, whereas on the other hand, bond making is exothermic. Okay? So how would you then find the energy where you have a reaction? How will you find the energy released or absorbed in a reaction? And this is a very important process. Okay? So this would be the energy for a reaction is equal to energy released when making bonds plus energy used to break the bonds. So what does this mean? This means that first you're going to require energy to break the bonds, and then you will release energy. So the energy released added to the energy absorbed is going to be equal to the energy of the reaction. Now, this might sound counterintuitive. This plus here might sound counterintuitive. But remember, the energy released, to show that it's being released, it will have a negative sign. Whereas the energy to break the bonds, to show that it's being absorbed, this will be a positive sign. So that is why we have put a positive sign there. That's why we add the two together. Okay? So let's do an example here. And let's use a fictitious example. Let's say that hydrogen bond, okay, is equivalent to 10 units of energy. Chlorine bond is equivalent to 12 units of energy. And HCl bond is equivalent to 15 units of energy. Okay, so here I am inventing the numbers. I am only using these numbers for this example. So if I have the reaction hydrogen plus chlorine to give 2HCl, I know that I will require okay, 10 units of energy to break the hydrogen-hydrogen bond, and 12 units of energy to break the chlorine-fluorine bond. Therefore, a total of 22 units of energy is required to break the bonds. On the other hand, I am releasing 15 units of energy for every mole, for every HCl bond broken, and I'm breaking 2 HCl bonds. So this will be a total of 30 units of energy released when making the bonds. And this is super important, okay? So, in this situation, I immediately wrote the negative in front of the 15 because I know this is going to be bond making. And because this is going to be bond making, then I'm going to be releasing energy. And therefore, this will be 30 units of energy being released. Okay, so this is something that we have to keep in mind. Okay, so here we have 22 units of energy required to break the bonds, 30 units of energy released when making the bonds. So total energy for this reaction is equal bond making plus bond breaking, where the bond making is going to be the minus 30 and the bond breaking is going to be the 22. So there you will have minus 30 plus 22. So this reaction will end up having minus 8 units of energy, or we can say that eight units of energy have been released. Okay, so this is how to work a bond breaking, bond making question. Okay, so let's actually rephrase. Every single reaction, you first need to break the bonds, then you are going to make bonds. To break the bonds, you require energy, whereas to make the bonds, you will release energy. Okay, so breaking the bonds is always an endothermic process, whereas releasing energy, exothermic, will be happening every time you make a bond. In order to find the energy released or absorbed in a reaction, we can then see the energy needed to break the bonds of the reactants, and we can also find the energy released when making the bonds of the products. Okay, so now it will be time for you to work a few questions. So now you can work a couple of questions on your own. Okay, remember, for the organic chemistry compounds, CH4, CH3Br, do the structural formula. It will help you visualize what kind of bonds you've got. Okay, and you can try this out. So what I would recommend is pause the video, work the questions, then I'm gonna work all the questions afterwards. Okay, pause the video, work the questions, then I'm gonna answer all the questions. What I would recommend, what I would like to advise is for each question, take your time. It's better to take your time and be a little bit slow and get these correct than it is to actually get them wrong. Okay? So take your time, these shouldn't be too hard. But take your time. I would also recommend that you work one, you see the video for that one to make sure that you are getting them right and that you've understood them. Okay? What I will try and do is I will try show all the working on the screen. So you can actually go on and consider, okay, everything else. So work them, pause the video, unpause when you finish the first one, correct it. If it's correct, do the other three. If it's not correct, listen to what I'm doing and try the other three. Okay? And again, you can do it with pausing and watching after B, C, and D. So CH4 plus Br2 to give CH3Br plus HBr. So here you have CH4, and CH4 is methane, plus Br2 to give bromomethane plus HBr. Okay, so there are two ways how to do it. First, we're gonna do it by breaking all the bonds. So you have 4 carbon-hydrogen bonds, which are gonna be 4-1-3. We are gonna break one Br-Br bond, and then we're gonna make 3 carbon-hydrogen bonds and 1 carbon-bromine bond. Okay, let's actually fix that number. And we're also making NHBr. The ones that we are making, they are going to be a negative because they are going to be exothermic. Okay, so we can actually write that negative immediately. So then we can count everything up, okay, and we can see what the values are going to be. Whenever you are working any of these out, I highly recommend that you try and do this, okay? You try and do this step by step, okay? I highly recommend that you try and do this step by step. So this will be 1652 plus 193, which will then give a value of 1845. So we have 1845 kilojoules in the bond breaking, and you're going to have 413 times 3, 1229 in the bond making, minus 280 minus 366. So at this point, okay, at this point, then you add all of them together. This will be minus 1885 kilojoules. So this is the bond breaking. This is the bond making. We're gonna add both of them together. So energy change in reaction. Energy of reaction is gonna be equal to minus 1885 plus 1845, which is gonna be minus 40 kilojoules. Okay, so this reaction would have an energy change of minus 40 kilojoules. Okay, so that's the first one. Let's do the second one. Okay, so now you're fine with this. I'm gonna be using the same space for the second reaction. Okay, and here we're gonna get two oxygens to give CO2 plus two oxygens out of waters. Okay, oxygen, hydrogen bonds. So here we can do the same thing, we can repeat. So it's 4 times 413, 2 times O double bond O is 498. Carbon dioxide, you will have 2 C double bond O, so it's 2 times minus 805. And again, we're doing the minus because we're doing the minus because we have an exothermic reaction is the bond making, okay? And we will have 4 OH bonds. So 4 times minus 464. Remember, it's 4 OH bonds because you have 2 waters and each water has 2 OH bonds, okay? So this would be 1652. 498, this would be 996. Okay, now I highly recommend that you do this step by step. And this would be a total of 2648 kilojoules. Okay, and I'm trying to keep all the bond breaking in one color. And then you will be releasing minus 1610. Okay, and minus 1856, and this will be a total of 3466 kilojoules. And this is going to be in yellow. Okay, when we add everything together for the energy change of the reaction, and do not forget the negative sign there, is equal to minus 3466 plus 2648, which is equal to minus 818 kilojoules. Okay, so do them slowly and you'll be able to get the answer. Now, the reason why I'm telling you to actually do the step by step is simply because at the end of the day, you will have marks for your working and you will also have marks for your answer. But if your answer is wrong and your working is correct, then it's fine. But if your answer is wrong and your working the examiner can't comprehend, then you would have a problem. Okay, so this was B here. Now let's actually work C and D. Okay, and again, if you got it right, you might want to do both C and D at once. If you're still having some problems, again, do one, and then you can work the other. So it's hydrogen plus fluorine to give 2 hydrogen fluorine bonds. So hydrogen is going to be 435, and fluorine is going to be 158. The HF is going to be 2 times minus 565. In this situation, we can immediately work do one for the endothermic for the bond breaking. This is going to be a total of 593 kilojoules. Okay. And for the exothermic, for the bond making, is going to be minus 1130 kilojoules. Okay, so then the total energy change is equal to minus 1130 plus 593, okay, which is equal to 537 kilojoules. For the last question, for D, so again, let's make sure that you've got this right. Okay, it's minus 537 kilojoules. For the last question, there's going to be something similar with nitrogen plus hydrogen to give ammonia. Okay, again, these do not seem to be that hard. Okay, so you should always be able to get them right. Okay, so D N2 plus 3H2. So remember, N2 is a triple bond plus 3 hydrogens to give 2 NH3s. So N triple bond N is going to be 945 kilojoules. Hydrogen bond is going to be 3 times 435. And you will have 6 nitrogen-hydrogen bonds. So 6 times 391, it's exothermic, therefore it's going to be negative. So you can start immediately by ensuring that you know what the totals are. Okay? And again, remember that I am doing these step by step so that I can always ascertain what I'm doing step by step. If I make a mistake, I can easily retrace my steps and see what's happening. Okay, so this is something that I find it very important. And the energy released would be minus 2346 kilojoules. Okay, and that is going to be there. For the final answer, energy is equal to minus 2346 plus 2250, and the answer would be minus 96 kilojoules. Okay, now, having done this, I would like to share a few words of wisdom about the first reaction. Okay, so this is always true. And it might save you some hassle later on in life when it comes to chemistry. In this reaction, these bonds are not being changed. Therefore, there's no need to include them when breaking and making the bonds. So in fact, we can see that you are only breaking one carbon-hydrogen bond, one bromine-bromine bond, and then we're making one carbon-bromine bond and one hydrogen-bromine bond. And in fact, if we were to use these values here, it would be 413 for the carbon-hydrogen bond. The bromine-bromine bond is going to be 193. Okay, the carbon-bromine bond is 280, and the HBr is going to be 366. Okay, so if we were to do energy equals minus 280 minus 366 plus 413 plus 193, okay? So this would be bond making and bond breaking. Okay, we will end up having the same answer that we originally had. Okay, we will end up having the same answer that we originally had, okay, without having had to work out all the question, okay, without having to break all the bonds and find out the bonds. So this would be 40 kilojoules. Okay, so that is something to keep in mind because it's something that you should know, you should be comfortable with. Okay, you don't need to have all the data as long as you have most of the data. For the last part of this lesson, okay, we're going to be studying energy diagrams, and then after this, we're going to be speaking about Hess's cycle, Hess's law. Okay, so for the last part of this lesson, we're going to be continuing on energy diagrams. Okay, it was not going to be that long, maybe 15 minutes. And then we are going to have a we'll be doing, we're continuing to lessons Hess's cycle in the next lesson. Thank you.